So today we're going to do a very cool problem. We're going to do combinations like we did before, but we're going to allow for repetition, which makes things just a little bit more exciting and more complicated. So let me start with a really simple problem. Let's consider the numbers 1, 2, 3, 4, 5. And what I want to do is I want to choose two numbers without any order. And again, nothing we do today is going to involve order because then that would be permutation. That's something else. So if I said, let's just choose two numbers, no repeats, no order, no nothing. We know this would be a combination. And my possibilities would be 1, 2. Actually, you know what? I'm gonna cheat. I'm gonna do this without parentheses. It'll just be a little bit faster. So I have 1, 2. I have 1, 3, I have 1, 4, I have 1, 5. Now what? I don't do 2, 1 because that's the same choice. So I do 2, 3, 2, 4, 2, 5. I don't do 3, 1. I don't do 3, 2 because I've already got them listed. So I do 3, 4, 3, 5, and then finally 4, 5. I'm picking two numbers. Okay, order does not matter. That's why I'm not counting 5, 4 as a separate choice. That would ordering them. And clearly I have 10 choices here. That would be 5, choose 2. So now what if I allow for repetition? What if I allow for the same choice more than once? And a really simple example, you're going to the ice cream parlor and you want, 2 scoops of vanilla. No, you can't have that. You must have different flavors. Well, I'm pretty sure you're allowed to pick the same flavor more than once. So if we're allowed to do repeats, then what would I be adding to this list? Clearly, I'd be adding 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Did I add enough there? Yes. So what does that give us now? That gives us 5 additional. That gives us 15. Now, how do we get 15? Can I do a combination and get 15? Is there any combination that produces 15? Well, actually there is. The combination 6, choose 2 gives us 15. And the reason I'm saying that one specifically, because I only picked 2 numbers. So the question is, how do I get from here to here in this scenario? So let me do another scenario because we're going to derive a formula. And I don't want it to be in any way complicated or ambiguous. This time, I'm going to slightly different problem. I'm going to take the numbers and only slightly different because I don't want it to take a long time. Consider the numbers 1 to 4, and now we're going to choose 3 from the numbers 1 to 4 because I want it to look different. So, and again, same rules, no order implied. So we would have 1, 2, 3, 1, 2, 4. Then from there, then what would I get next? Then it looks like 2, 3, 4, and that's pretty much it. Actually, you know what? Nope, sorry. Let's do one more number. There's not enough here. Sorry, let's do 5. My bad. That's just not enough. Okay, so same thing. We'll do 1, 2, 3, 1, 2, 4, 1, 2, 5. Then 2, 3, 4. 1, 2, 3, 1, 2, 4, 1, 2, 5. Oh, no, let's stick with 1 first. Sorry. Then we'll go 1, 3, 4, 1, 3, 5. Then 1, 4, 5. Make sure my brain's working properly. I think that's it. Then we'll go 2, 3, 4, 2, 3, 5. Then 2, 4, 5, and then finally 3, 4, 5. I think this is every possible combination. So if I have 5 numbers and I want to choose 3 of them, clearly that's 5, choose 3, which of course is 10. And that's how many I have. So now what if I allow for repeats? Then once again, if I'm going to allow for repeats, if I've got everything up here, which I think I do, I think I've got everything up here. let's see, 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 3, 4, 1, 3, 5, 1, 4, 5, 2, 3, 4, 2, 3, 5, 2, 5. Yes, I had to go through and make sure I got them all. Now, if I allow for repeats, this is going to be a little bit tricky. So repeats would be what? 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, oops, don't want the parentheses there, 1, 1, 4, 1, 1, 5. 2, 2, 2, 2, 2, 3, 2, 2, 4, 2, 2, 5, 3, 3, 3, 3, 3, 4, 3, 3, 5, 4, 4, 4, 4, 4, 5, and finally, I think 5, 5. Do we have that? Actually, no. I think I've left something off here. Did I leave one off? 1, 2, 3, 4, 5, 6, 7, 8. Oh boy, I think I've left off a couple. See, 2, 2, 2, 2, 2, 3, 2, 2, 4, 2, 2, 5. Oh, I did leave one off. Sorry. 2, 2, 1. Sorry, left off 2, 2, 1. And then with the threes, I've left off a 3, 3, 1 and a 3, 3, 2. There we go. And the fours, I've got a 4, 4, 1, a 4, 4, 2, and a 4, 4, 3. With the fives, there we go. 5, 5, 1, 5, 5, 2, 5, 5, 3, and 5, 5, 4. That's a lot of extra guys if I count the repeats. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Exactly 25 if I allow for repeats. That means I would have 35. How the heck can I get 35 if I'm choosing 3? Well, let's see. Are there any factorials that would give us 35 if I choose 3? Yes. Strangely enough, 7 choose 3 would be 35. So when I just picked 3 with no order, that was a simple combination. 5 choose 3, we got 10. Now that I said we are allowed for repeats, we got a whole bunch more, but it's really not the number. It's how do I get from here to here? So now I'm going to draw you a picture. Because the formula itself is not difficult to use, but I don't think it's intuitively obvious. Clearly, in my choices, I'm choosing 3 in each case. In the previous example, I was choosing 2 in each case, but how do I change my numerator? So let's go back to the first example where we did 1 through 5. And I want you to think about it as I have 5 categories, and these categories are separated. Let's say I'm going to put a partition here. I'm going to do 3 different examples here. So that'll be the first one, and then that'll be the second one, and the third one. So I have partitions between the different categories. And now I'm going to make a selection. So let's suppose in the first case, I selected 1, 3. So that means I'm going to do there and do there, but I also have a partition here, a partition here, a partition here, and a partition here, okay? Let's say in the second case, I'm going to do 4, 5. Okay, well, that means I have a partition, nothing there, a partition with nothing there, a partition with nothing there, and then I X out here, a partition, and then I exit out here. Okay, so I can think of literally a space, 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 X, X. And then let's suppose I do a repeat. I do a 2, 2. Well, that means I have nothing here, a partition, 2 X's, a partition, a partition, and a partition. So if I thought about it and all of the ways that I could put X's in here, we had 15. Okay, we had 15 altogether. We did 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. When I allowed for repetitions, we got 15. But if I'm looking at my picture, It's really, I have 4 partitions, I have 2 X's. Okay, I have 4 partitions, and the partitions are natural because I have 5 categories. So if you can think of it this way, I have 5 minus 1 partitions. But 4 partitions and 2 X's, that's 6. Remember, our answer was, in fact, 6 choose 2. So it turns out the way I can come up with the 6 choose 2 is to take the number of categories, that's 5, I'll put here, minus 1. Okay, so 5 minus 1, that's the number of categories. I am choosing 2 of them. So I'm going to add 2, and I'm going to choose 2. 2 is how many I'm choosing, but because I'm repeating, this would represent the repeats. Okay, this is where we got our 6 choose 2. Now think of the second example that we did. In the second example, I took the same 1 through 5, so I'd have the same 4 partitions, but then we chose 3. So in the second example, we would have had 3 plus 5 minus 1, and we chose 3. And notice that gives us our 7 choose 3, which was the answer the second time. So I'm giving you sort of a simple way of thinking about it when I'm partitioning. Okay, so the number of categories, that's my n. I'm choosing from the numbers 1 through 5. I have n categories. That means I have n minus 1 partitions. I'm choosing r things, but since r is allowed to repeat, that means I have r x's, if you will, and n minus 1 partitions that I must now choose from where I want them. So the formula, the simple formula that we now have, and the way we say it is, in the textbook, the author refers to them as the R partitions. And you can call it that. Excuse me. So the number, okay, we have a set of size n. We're going to choose R with repetition. In other words, we're going to allow for repetition. Okay, then the number of ways is R plus n minus 1 choose R. Now here's what's interesting about this case. R does not have to be smaller than n. So what do you mean I don't have to? From my numbers 1 through 5, what if I said, I want you to pick 10? Of course, you get to repeat. So you could pick the number 1 10 times. You could pick the number 2 5 times and then the number 3 5 times. For my numbers 1 through 5, that's n numbers, you're going to choose R, but R can be any integer, any positive integer. Because I can repeat, R is no longer restricted by having to be less than or equal to n. That's kind of cool. Okay, that allows for a lot of things. So you might say, well, you know, that particular pizza place, they have 5 different toppings, but I want a 10 topping pizza. Well, then obviously you have to have some repeated toppings. Okay, at the ice cream store, right, they have 10 flavors, but I want, you know, a bowl with 20 scoops in it. Well, obviously I have to have some repeated things. So R can exceed n in this case. So let's look at some examples. The formula is actually extremely simple to execute. It's just this. N again represents the number of things I'm choosing from, and R represents how many things I'm choosing, allowing for repetition. Again, that's the key. I'm allowing for repetition. If I'm not allowing for repetition, then it's just straight out N choose R like it was before. That part doesn't change. Excuse me. So let's start with a simple example. Let's say that the 40 students in Math 245, okay? And let's suppose that I have, let's say I have movie tickets that I want to give away, okay? So I have 10 movie tickets. And it can be really simple. I'm going to have a little drawing. So I'm going to put everybody's name into a hat, mix them up, and I'm going to draw 10 names out. Now, let's keep it simple. The 10 tickets are all for the same movie. So being chose first, being chose 10th doesn't make any difference. It's, you know, some new blockbuster movies coming out, and I'm going to give away 10 tickets. Now, how many ways can I do that? Well, we know it's simple. It's 40 choose 10. Okay, because we just determined that order did not matter. So we calculate that 40, choose 10. And that would be, ooh, that's huge. That's a lot of possibilities. That is 847 million 660,528. All right. Now I'm going to change it a little bit. I'm going to give away 40 tickets. But let's suppose that every time you did something wonderful in the course, every time you did something great, you get to put your name into a hat. But many of you did tremendous deeds. So some of you have your name in the hat maybe 50 times, 100 times. Your probability of getting selected is going up at all times. But let's suppose that every person in the class could be selected more than once. So it could be that Cindy gets all 10 tickets. That's a possibility. Everybody in the class. So an easier way to do it is I pick a name, I look at the name, and then I throw the name back in, and then I mix the tickets around again. So in other words, everybody in the class can be selected multiple times. In fact, each person in the class could actually be selected all 10 times. Now how many? So if I did it with repetition, so probably the easiest way to think about this is just basically every time I look at a name, I put it back in. If you had some raffle, for example, every time a name is chosen, that person wins the prize, that's it. But at a typical raffle, couldn't somebody buy multiple raffle tickets? So in other words, their name may be in the bag multiple times. Well, in this scenario here, every time I pick a name, I either set it aside or I pick a name, I look at it and I throw it back in. So if I throw it back in, that means that repetition is allowed. So how does this change? Well, 40 is still my N, 10 is still my R, but now the formula becomes what? It becomes 10 plus 40 minus 1, choose 10, or 49, choose 10. Now that's going to significantly change my numerical value. Yikes. This is going to make it almost 10 times bigger. Now the answer is going to be 8,217,822,536. So allowing for repetition, okay? Allowing for repetition changes it significantly. All right, here's another one. Oh, and by the way, some people think it's a myth. It's not. Me and my wife and my son went to Krispy Kreme yesterday and got a free donut because we were vaccinated. We just had to show our card. So I'm going to use donuts next. So I go to the donut store and I want to bring, let's say, I want to get, I don't know, 10 donuts. Maybe I want to get 20. I want to get a bunch of, dozens. Okay, I should start with 12s probably. I want to get a bunch of donuts. All right. But at the Krispy Kreme, they got a lot of different types of donuts. They have a lot of different types of donuts. And in fact, they have a lot of different types of donuts. And then they have a lot of each of those types. So if I said, I want to get whatever, they're probably not going to run out. So I'm going to go to Krispy Kreme and let's just say I want to get, I don't know, I want to buy 2 dozen donuts. I'm going to get 24 donuts. All right. So you're going to go get 24 donuts. And I have no idea how many different donuts they have there. So let's just make up a number. Let's say there are, I don't know. Let's say there are 10 different types. There are 10 different types of donuts. Excuse me. And I want to bring 2 dozen donuts, home to the family, to friends, whatever. I want to bring 2 dozen donuts. Well, most of you, if you went out and got 2 dozen donuts, you wouldn't be concerned with making sure you had 24 different donuts. No, you just want to make sure you have 24 donuts. Maybe you got 24 and you made them all the same. Okay, that's totally okay. I went out and got 24 glazed donuts. Or if you're like me, you want, you apple fritter. That's like the most important one. You got to have your specific ones. But the question is, how many ways could I do that? If there's 10 different types of donuts and I want 24 donuts, obviously I have repeats. Otherwise, I'd only have 10 donuts. So how many ways can I do this? Well, there's only one assumption that we're going to make here. And that's it, that they have enough donuts that you could get 24 of the same type of any of the donuts they have. That's a simple assumption, because without that, it's a little more complicated calculation. So what is the N and what is the R? Anybody want to yell out what is the N in this case and what is the R? Because this does matter.
N would
Is
be
the-
donuts and R would be the types.
So
Well,
N is
number, give me a
24,
number.
right?
N
Is N is
what?
24? N 24, R 10?
No.
It's the
Oh,
other way
it's
around?
backwards.
How many
10?
different- I have 10 different, I have 10 categories, 10 different donuts.
So that's N.
Yeah, see, that's what's throwing you. Go, oh, remember I said R could exceed N. Why? Because I'm allowing for repeats. Is there a common error about to take place if I don't do this? Of course, I'll have the wrong numbers in my calculation and I'll get a large calculation, but it won't mean anything. So I have 10 categories. So number your donuts 1 to 10. You know, donut 1 might be glazed, donut 10 might be, you know, eclair. I don't know. And now you say, let me put my X's in each category. See, I want 5 of these and 2 of these and 3 of these and 6 of these and 7. Basically, you fill up your 24 donuts, but you're choosing 24 donuts. Hopefully that helps you. When we think N choose R, I had N categories and I chose R things. If I was forming the basketball team from our discrete math class, I had 40 students, I'm choosing 5 of them. That's 40 choose 5. I am choosing 24 donuts. That's why that's 24. I had 10 choices to select from. So the answer to this question will be 24 plus 10 minus 1, choose 24. The common error, obviously, is to switch the 24 and the 10. And unlike a regular combination, that won't give you the same answer. Let me show you what I mean. Let me erase this. We know in a combination, we know that N choose R is equal to N choose N minus R because they both yield this quantity. Another way of thinking about it, if you have R distinct objects, the number of ways of choosing N of them is equal to the number of ways of choosing which ones you don't want of the N minus R remaining. So I'm picking 5 people on our basketball team of 40 students. That's equivalent to me picking which 35 people I don't want on the basketball team. Okay. But in this case, it doesn't work. You can't switch the N and the R. In other words, R plus N minus 1 choose R is not equal to R plus N minus 1 choose N. Okay. I can't do that. You can't swap the 10 and the 24. A lot of folks will make that mistake. I'll get a different numerical value. Will it be way off? No, but it will be off because in this case, R and N minus R both add up to N. In this case, R and N don't add up to R plus N minus 1. So it's not the same thing. So in this case, our donut example, hopefully I'm not making y'all hungry here. Our answer would be 33 choose 24, which is large. That gives us, oh, my pens are all over the place, 38,567,100 ways. Oh my gosh, the pressure's on. I got to go to the donut store, pick up 24 donuts, and I've got over 38 million ways I could do this. Fortunately, I don't have to write them down. I just have to make my selections. Okay, so this is a fairly simple execution. Now, one of the really cool problems that I like to look at in this case here is I want to solve an equation. For those of you in linear algebra, solving systems of equations is no big deal, but parameterizing systems of equations is a big deal. And in fact, it's not just the parameterizations to talk about the numbers of solutions. One of the problems I like doing early on in the course is the traffic flow problem. I have intersections that can handle this many cars and this many cars are leaving. And you end up with a whole bunch of equations that look something like this. I want to solve x1 plus x2 plus x3 plus x4 plus x5, let's say, is, I don't know, 40. I want to solve this equation. Well, first of all, if I don't put any restrictions, that obviously there's an infinite number of solutions. Right off the bat, there's an infinite number of solutions because all my X's could be positive, they could be negative, they could be rational, they could be irrational. So let's put some restrictions. If this were a traffic flow problem, sometimes it's called a sources and sinks problem. Linear algebra, we do this. I do this on day 2 of the semester. We're doing a traffic flow problem, and X1 would represent the number of cars at each intersection. So let me give you a typical example of what this would look like. We're not going to do the linear algebra. So I might have 4 junctions, we call it. And each junction would represent an intersection. Each of these would represent streets. So I am feeding into this junction and I'm leaving this junction here. Okay, maybe I'm feeding into this junction and maybe this junction I'm also leaving. So the idea is how many cars per minute, per hour, whatever could each junction handle. And the reason this kind of problem is so important to understand is if there's any road construction, you have to divert traffic, you have to understand how much each can take. So maybe I have that being another one. So I'll call, and let's say this one only goes in this direction, this one only goes in this direction, this one only goes in this direction. Let's say this one only goes in this direction. And how about this one goes in this direction? All right. We'll call this X1. This would be, let's say X2. This is X3. This is X4. This is X5. I might say there's 1,000 cars feeding into here, and there's 500 cars feeding into here, and 800 cars are leaving here, and 700 kind of has to add up. Right now, there would be exactly 4 equations, one for each junction. Okay, and the equation, for example, for the first junction, the amount going in has to equal the amount coming out. Otherwise, you have cars falling into black holes, which is below average. So the first one, I have 1,000 in, and I have X1 plus X2 plus X3 coming out. So my first equation would be this. And then I do the same thing for here. I do the same. So in other words, I set up a system of equations that all look sort of this form. And then I solve them, I parameterize, and I go on. So that's where something like this could easily come from. This is, by the way, the lowest level. What do I mean? Well, a downtown usually has more than 4 intersections. A downtown might have 100 intersections. Oh, so I have equations with maybe a lot more than 5 variables. But this is just the basic idea. I want to solve this equation, but if this is representing traffic flow, then there are certain restrictions on the X's. First of all, if it's traffic flow and X represents number of cars, I don't think X can be an irrational number. I don't think X can be a fraction. I'm pretty sure X can't even be negative. And by the way, that would be bad. That means cars are coming at you on the one-way street. No, I think X would have to be a non-negative integer. Oh, okay, that makes sense. So I'm going to put restrictions. The Xi, we'll say, is non-negative. Well, that does change things. Why? Because when I first wrote the problem down, clearly there's an infinite number of solutions. Now that I'm saying X is non-negative, there is no longer an infinite number of solutions. There is a finite number of solutions. Oh, in fact, could all 25 be X1? Yeah. Any of these could equal 25. Agreed?
Of course, yes.
In fact, think of non-negative integers only. Just have fun. I can say, 10 plus 10 plus 10 plus 10 plus 0. That's a solution. And 5 plus 3 plus 8 plus 16 plus 8. You could start going on, but there would definitely be a finite number of solutions. So how many solutions are there? Well, think about this as a categories thing. I have 5 categories. And let's think of 40 as the number of cars, because that's really what it is. And I can start doing things like this. Well, in category 1, I'm going to put, 3 cars. In category 2, I'm going to put, 7 cars, and so on. Kind of like what we did at the start. I can think of 40 individual units, cars, and I'm going to disperse them into the categories. How many ways can I do that? This is exactly the formula we just derived. This is the number with repetition allowed. Okay, so what is my N? What is my R? I don't need this, but it's the same concept right here. So in this case, what is my N, everybody? By the way, there's only 2 numbers in the problem. There's a 5 and there's a 40. So far, that's all you got. Which one's N and which one's R?
N is 40.
What does N always represent? Always. By the way, I'm not talking today. I'm talking for the last 2.5 weeks. What is N represented in every case? The number of things you are choosing from, the number of categories. You don't have 40 categories. I could put any positive number here and it wouldn't change the problem. I still only have 5 categories.
Just 5 categories?
So 5 categories, N is the number of categories. By the way, of all of the things we're going to do this semester, this has to be the easiest thing because there's no thought required and there's no calculation, but you gotta pay attention. You have 5 categories. I just even laid it out. You have 5 categories. You have 5 categories. You're choosing from 5 categories. If I said I want to pick a basketball team from the discrete math class, I have 40 students. I want to choose 5 people in the basketball team. I have 40 people to choose from. I have 40 categories. Okay. The categories are what you're choosing from. How many you choose can change. I could put any number here and I still only have 5 categories, but this says I'm choosing 40. Why does that matter? Because the formula depends on how to get these right. So the answer to this question is 40 plus 5 minus 1, choose 40, which is large, but not that large. So this is 44, choose 40. Which is 135,751.
That's not actually that large when compared at least to the other numbers.
When compared to infinity, certainly. Now, in a traffic flow problem, you're not doing this calculation in a traffic flow problem. You're actually just simply representing your answer in a parameterized version of that. Different goals, different results. But when you come right down to it and you say, well, I've got all of these possibilities, is it unlimited? Well, can this problem be unlimited? Yes. I use this as a traffic flow problem. What if instead of cars, these represented tubes? Maybe I'm in the city waterworks, and you've probably seen, even on movies, all the tubes with the water coming from every direction, and maybe that's where I'm purifying the water and I'm sending it out. But I have water flowing in one direction down these tubes. But water wouldn't have integer values of quantities of water. You see? So in that case, it would be any positive real number. Now that would be a problem. But in this case, we're saying x1 represented a non-negative integer. So exactly how many solutions does this equation have? If x's are non-negative integers, so I have this many. If x represented a non-negative real number, now you'd have infinitely many, unfortunately. Does that make sense? Hopefully. That by the way, we're not looking at that problem. That problem doesn't interest us because if it's infinite, then there's no calculation involved. So I want to do one more example. Okay, I want to do one more example, and let's say I have 20 books, and they're different. I have 20 different books. Okay. Now there's 3 different questions that I can ask. Well, first of all, I can say, how many ways can I put these books in order? We know the answer is going to be 20 factorial, but that's not what I want. I want to select, I have 20 different books, but I might be a bookstore. So I have 20 different books, but I might have 1,000 of each of those books. So in other words, the best-selling novel, hopefully I have lots and lots and lots of copies of that books, but I have 20 different books. Okay, I have 20 different books. And so next week, I want to do a display. Maybe I want to and I'm going to pick out, let's say, just 4 books. So I'm going to choose 4 books. Now there's a whole lot of ways I can do the next thing. I want to do a display, and maybe I want to do a display by my largest selling books, my top 4 selling, titles. I guess that would be the right word. And I want to put them out, out in display right in the window for everyone to see. So how many ways could I display my top 4 selling books? Anybody want to try that one? What type of problem would that be? I want to display my top 4 selling books. First of all, does order matter?
No, because you're not ranking them.
I want to display my top 4 selling books. Finishing first in the race, is that the same as finishing fourth in the race?
No,
I'm pretty sure this is the only scenario you can think of where order absolutely is the only thing that matters. Yeah. The top selling book followed by the next top selling book followed by next. Yeah, order matters because whichever one's first is the top selling book. The next one, if you're in a race, first, second, third, and fourth is not interchangeable. No, I want, so first question is I want to choose 4 books and I want to put them in the order of the top 4, 1, 2, 3, 4. So that's a permutation.
the 20p4.
24. Now, that's, I said, there's several ways I can ask a question. That's the first question. Second question is, I want to choose 4 books because I want to, maybe I want to give them to a friend, or maybe I just want to choose 4 books so I can put them in my office to read later. I'm going to pick 4, but I want them to be different books. I'm going to pick 4 books. Am I putting them in order if I'm going to pick 4 books and go put them in my office, or 4 books that I'm going to pack in my suitcase to take on my trip with me? Would the order matter in that case? I'm grabbing 4 books. Anybody? Not putting them on display. I'm just grabbing 4 books.
No, it wouldn't matter.
Yeah, it's like I'm grabbing 4 books simultaneously. So in this case, it wouldn't matter because I'm grabbing 4 books. First case, I'm setting up a display of the best selling on down, top 4 selling books. Now I'm just going to grab 4 books. Now I might be putting them on display, say, hey, these are the types of books we sell. And I could have grabbed any 4, including the 4 worst selling books. Who knows? I just grabbed 4 books. So the second one clearly is this. Now I've got all of these books. Now the shipment just came in and they decided rather than put each type in a different box, they have just one big old bin. Kind of like when you go to the bin at one of the grocery stores or one of the stores and they have all the CDs or all the DVDs in a bin, like 500 DVDs just in a bin, but you'll have the same DVD over and over again. They just dumped all the books on the floor. I've got hundreds and hundreds and hundreds of books. They just dumped them all on the floor. Oh my gosh, I don't have time to go through this, but I told my friends that I would bring some books home with me. So I'm going to grab 4 books. I'm just going to grab 4 books from this big pile of hundreds and hundreds and hundreds of books. Remember, we have 20 different books that we sell. There's a pile of hundreds and hundreds and hundreds of books sitting on my floor in the middle of my store. Obviously, the same books are over and over and over again. I'm just going to go grab 4 books and not look at which ones I grabbed. Do I have to consider the possibility of repetition in this case? What do you think?
Yes.
Yes. Does the order matter? I'm going to grab 4 books. I'm grabbing 4. Does order matter when I'm grabbing 4 at one time?
No.
No, but repetition does. So what's the answer to the last question? Well, the way we've set this up, isn't it pretty obvious that the N is 20 and the R is 4? Isn't that obvious? Because of the way we set it up? Because that's the formula. So what's the answer in the last case? So do you see the consistency? Oh, from my 20 titles, I'm going to choose 4 and put them in order. From my 20 titles, I'm just going to choose 4, any 4, but I'm not going to put them in any form of order. For my 20 titles, I just grabbed 4 books at random, but I had so many books and it was dark and I didn't even see which ones I grabbed. They're all the same size. I could have grabbed the same book 4 times, the same title 4 times. I could have grabbed 4 different titles. But the last case is the repetition allowed. But I want you to see the consistency of the formula. That's very, very important. In each case, I chose 4. So 4 is the number that goes here. Now, could I now say, hey, you know what? I got a lot of friends and colleagues, and I want to give them Christmas presents this year. I want to give out 100 books as presents this year. I want to give out 100 books. I only have 20 different titles. Now, I have a lot of books. I have, maybe 1,000 of each one in my warehouse. I'm not going to run out of books. But if I said I have 20 different titles and I want to give away 100 books, first of all, is repetition possible?
Yes.
Kind of have to. I only have 20 different titles and I'm giving away 100 books. I'm giving away 100 books. How many ways can I do that? Anybody want to try that one? I'm giving away 100 books. Well, did the number of categories change? Or is it still 20?
Still 20.
Yeah, it's still 20. I'm giving away 100. I'm giving away 100 books. So what's the 100 in this case?
Your choose, your R.
That's my R. Yeah. N is still 20, but now I'm going to give away 100 books. And if you think about it logically, you go, oh yeah, I want to give presents to people. I might be given the same present, just make sure they don't talk to each other because then it looks bad. So what would the answer to the last question be? I'm giving away 100 books. Well, pretty sure that's going to go there. Anybody want to tell me what goes on top?
100 plus 20 minus 1.
Beautiful. That's it. You got it. This is how you do it. They're called R combinations with repetition. It's kind of wordy, but it's not the same type of combination that we did before. Because before, the things you're selecting couldn't exceed the number of categories because you're only selecting one of each thing. Now I'm saying, no, I'm going to allow for repetitions. So if my 10 different books, I might be giving away 1,000 books. Okay. So I can give away as many books as I want because I'm allowed to repeat. But if I said, no, I have to give a different book to each person, then obviously I cannot give away more than 20 books then. Okay, so that's what we wanted to get to today. That's, like I said, it's not